applications of derivatives, in that increasing and decreasing function. So first of all, increasing function. So here, for increasing function, a function f is said to be monotonically or strictly increasing function on an interval AB if for any x1 y1 belongs to open interval AB with if x1 is less than x2, we have f of x1 is less than f of x2. Now consider an increasing function y is equals to f of x in the interval a to b and hb, and let h be greater than 0 with a small increment in x. So therefore, as x is less than x plus h, so this implies f of x is less than f of x plus h, as f of x1 is less than f of x2. So that is f of x plus h is greater than f of x. So therefore f of x plus h minus of f of x is greater than 0. So we divide by h on both sides. It means f of x plus h minus f of x divided by h is greater than 0. And lastly we take the limit as h tends to 0 on both sides. It means limit h tends to 0, f of x plus h minus f of x divided by h is greater than 0, and this implies, this is the definition for derivative, it means f dash of x is greater than 0 or greater than or equals to. So f dash of x is greater than or equals to 0. It means that a function is increasing whenever its derivative is equals to 0 or positive. It means whenever derivative of a function is positive, then the function is increasing. If f dash of a is greater than 0, then the neighborhood of a is a minus of delta a plus delta. Then f of a is increasing whenever f of a plus h minus f of a divided by h is greater than 0. Hence, if 0 is less than h is less than delta and f of a plus h minus of f of a is greater than 0 and f of a minus of h minus f of a is less than 0, it means for positive value f of a plus h minus f of a is greater than 0 and f of a minus of h minus f of a is less than 0. Thus, for 0 is less than h is less than delta, f of a minus of h is less than f of a is less than f of a plus h. Now, we simply consider whenever the derivative of function is positive or equals to 0, then the function is increasing. Now for decreasing function, a function f is said to be monotonically, means strictly decreasing on an interval open interval a to b if for any x1 x2 belongs to interval ab with x is less than x2 we have f of x1 is greater than f of x2, then the function is decreasing. Now again consider f of x, consider a function y is equals to f of x in the interval a to b and h be greater than 0 with a small increment in x. So therefore x plus h is a decreasing function, means x plus h is greater than x. So here x is equals to x1 and x plus h equals to x2. So therefore f of x is less than f of x plus h. So here f of x1 is less than f of x2. So this again implies f of x plus h minus f of x is less than 0. We divide on both sides by h. It means f of x plus h minus of f of x divided by h is less than 0. And we take limit h tends to 0 on both sides. So here f of x plus h minus of f of x divided by h is less than 0. And this is nothing but f dash at x is less than 0. Or we say less than or equals to 0. That is, whenever derivative of f of x is negative, then the function is decreasing. Again, if f dash at a is less than 0, then delta neighborhood of a means a minus of delta, a plus delta. We have f strictly decreasing, means f of a plus h minus f of a divided by h is less than 0. Hence, for 0 is less than h is less than delta, f of a minus of h is greater than f of a is greater than f of a plus h. So here a function f of x is a decreasing function whenever its derivative is less than 0. Now consider the example. Show that the function f of x is equals to x cube plus 10x plus 7 for x belongs to set of real number is strictly increasing. Strictly means monotonically increasing function. So here for solution given f of x is equals to x cube plus 10x plus 7, differentiate with respect to x. It means derivative of f is f dash of x is equals to, now derivative of x cube is 3x square plus derivative of x is 1, means derivative of f of x is 3x square plus 10. Now here 3x square, so as 3x square is always positive, it means is greater than or equals to 0, that is 3x square plus 10 is greater than 0 for all x belongings to set of real number and 10 is greater than 0. So therefore f dash of x is greater than 0, and as derivative of f of x is positive, so therefore f of x is strictly increasing function. Now similarly consider the second example. Test whether the function, so here f of x is equals to x cube plus 6x square plus 12x minus of 5 is increasing or decreasing. Now here given f of x is equals to x cube plus 6x square plus 12x minus of 5. So we differentiate with respect to x. So f dash of x is equals to derivative of x cube is 3x square plus 6 into derivative of x square is twice of x plus 12, derivative of x is 1. And into derivative of 5 is constant term 0. So f dash of x is equals to 3x square plus 12x plus 12. So we take 3 common, it means x square plus 3 fours are, again 3 fours are, x square plus 4x plus 4. So this is simply equals to x plus 2 square of this one, and this is always positive for all values of x belonging to R except x is not equals to minus of 2. So here whenever x is equals to minus of 2, its value is equals to 0. So therefore is always positive for x is not equals to minus of 2. So therefore f dash of x is greater than or equals to 0 for all x belonging to set of real number, and as the derivative is positive, so therefore f of x is increasing function. Now consider an example. Find the value of x for which f of x equals to x cube plus 12x square plus 36x plus 6 is monotonically increasing and monotonically decreasing. So with the given function f of x is equals to x cube plus 12x square plus 36x plus 6. So differentiate with respect to x. So your derivative of f of x is f dash of x is equals to derivative of x cube is 3x square plus 12 into derivative of x square is twice of x plus 36 into derivative of 1, x is 1 and derivative of 6 is equals to 0. So f dash of x is equals to 3x square plus 12 to the 24x plus 36. Now we take 3 common, it means x square plus 8x plus 12. So here f dash of x equals to this thing. So factor of this one, 6 to the 12, it means 3 into x plus 2 x plus 6. So f dash of x is equals to this one. So our first problem, f of x is monotonically increasing function. Now increasing means what? F dash of x is greater than 0. So therefore 3 into x plus 2 into x plus 6 is greater than 0. It means x plus 2, x plus 6 is greater than 0. Now product of two number is greater than 0. It means product of two number is positive. So both the numbers are positive or both the numbers are negative. So therefore here either x plus 2 is greater than 0, x plus 6 is greater than 0, or x plus 2 is less than 0, x plus 6 is less than 0. It means both value, here say and, here also say and. Either x plus 2 is greater than 0 and x plus 6 is greater than 0, x plus 2 is less than 0 and x plus 2 is less than 0. So we consider first case. So in first case, whenever x plus 2 is greater than 0 and x plus 6 is greater than 0. So here this one is x is greater than minus of 2 and x is greater than minus of 6. So here x is greater than minus 2 and x is greater than minus of 6. It means that x must be greater than minus of 2. Now for case second, here x plus 2 is less than 0 and x plus 6 is less than 0. It means here x is less than minus of 2 and x is less than minus of 6, means x is less than minus of 2 and x is less than minus of 6. So therefore x must be less than minus of 6. So therefore f of x is monotonically increasing if x is less than minus of 6 or x is greater than minus of 2. Hence x must be belongs to, for x is less than minus of 6 means infinity to minus of 6, or x is belonging to, again here, minus of 2 to infinity. So this is the value for x whenever f of x is monotonically increasing. Now we find the value of x whenever f of x is monotonically decreasing function. For second one, f of x is monotonically decreasing. Decreasing means what? F dash of x is less than 0. So therefore f dash of x is less than 0. It means here 3 into x plus 2 into x plus 6 is less than 0. It means x plus 2 into x plus 6 is less than 0. It means product of two number is negative. It means one of them must be negative. It means either x plus 2 is negative or x plus 6 is negative. So therefore either x plus 2 is negative and x plus 6 is positive, or x plus 2 is positive and x plus 6 is negative. It means either x plus 2 is less than 0 and x plus 6 is greater than 0, or x plus 2 is greater than 0 and x plus 6 is less than 0. So case first one. So here whenever x plus 2 is less than 0 and x plus 6 is greater than 0. It means here x is less than minus of 2 and x is greater than minus of 6. So therefore for x belongs to the interval minus 6 to minus of 2, f of x is monotonically decreasing. Now case 2. So in case 2, x plus 2 is greater than 0 and x plus 6 is less than 0. So therefore x is greater than minus of 2 and x is less than minus of 6. It means the value of x is greater than minus of 2 and x minus of x less than minus of 6, which is not possible. So which is possible. So therefore minus 6 is less than x is less than minus of 2 is the required value of x. Now check whether the functions are increasing or decreasing. So here first one, f of x is equals to x cube minus of 6x square minus of 12x minus of 16. X is belongs to R. And second example is f of x is equals to x minus of 1 divided by x. X belongs to R and x is not equals to 0. We know for increasing and decreasing, if derivative of f of x is positive, then function is increasing, and if the derivative of f of x is negative, then the function is decreasing. So here for first example, given f of x is equals to x cube minus of 6x square minus of 12x minus of 16. So derivative of this one means 3x, derivative of x cube is 3x square minus of 6 into derivative of x square is twice of x minus of 12, derivative of x is 1 minus of derivative of 16 is 0. So this is equals to 3x square minus of 12x minus of 12. So we take 3 common. It means here x square minus of 4x minus of 4. So this value is x cube minus of 6x square minus of 12x means plus 12x. Here plus, here plus, so here plus, here plus. So this is equals to 3 into x minus of 2 square of this one. So f dash of x is equals to 3 into x minus of 2 square, and which is always positive, which is always positive. So therefore for x is not equals to 2 means for x value of x is equals to 2, this value is equals to 0. So therefore f dash of x is greater than or equals to 0 for x belonging to R, hence f of x is increasing function. Now for second one, again here f of x given x minus of 1 divided by x for x belongs to R and x is not equals to 0. So differentiate with respect to x. So derivative of f of x is f dash of x. Here derivative of x is 1 minus derivative of 1 divided by x is minus of 1 divided by x square. So f dash of x is equals to 1 minus minus plus 1 divided by x square, and this value is always positive, which is always positive. So therefore f of x is increasing function.